My colleague, Danny Kimmel, I worked with for about a year. And Danny's been working on a analytics framework to use in Delphix as with many systems companies. Performance is very important to us and very important to our customers. So Danny's going to talk a bit about construction of that. And I'm going to build frameworks around the data throughout now.
Can everybody hear me okay? All right, cool. So I'm Dan Kimmel. Nice to meet you all. I've been working at Delphix, like I was there for about half a year, and I've been working on building a framework that wraps DTrace and some higher level operations that our users are able to understand. So a little bit of background on what I've been building. We've been working on this framework on Lumos using DTrace. We're using it to monitor the performance of Delphix's product, which is basically a data virtualization engine. And in case that doesn't mean anything to you, basically all it means is database storage virtualization. And I'll go into a little bit more detail about what that looks like. Our users are listed TPAs we're using in the database that we're virtualizing the storage for. And the monitoring framework hasn't been released yet, which is why I went through that. So when I started out working on this project, my first concern was what statistics do we need to collect? It turns out that database administrators really only care about one statistic when it comes to the storage for the database, and that's I/O latency. The reason for that is that I/O latency drives the I/O latency for the database and eventually the service latency for the user. So when the users are unhappy, the database administrators are unhappy. So obviously, storage needs to be fast. In order to actually make the data, something that the database administrators can act on, we need to give them more than just the latency data. And luckily, DTrace is amazing at coming up with new ways of looking at that. So, at a very high level, this is what our product looks like. You have a database process that's connecting over a network and talking to a storage backend. But naturally, it's not actually this simple. It looks a lot more like this. The key of this slide is not to understand every level of it, but basically, you have the database process talking to the OS that it's running on. That's talking over the network to the hypervisor, which is running our product. Our product has several different layers in the file system that can be probed with DTrace. Finally, we're running on top of some storage, actual hardware. The important part of this is that the I/O path is looking a lot more complicated now than it did before. There's a lot more layers to get latency inserted at. And the beautiful thing about DTrace is that we're able to probe whatever layers we want to. So here are some of the statistics that we're concerned about. Sources of latency are highlighted here on the right, and potential bottlenecks are shown on the left. We're worried about the bandwidth limits, CPU and memory limits, whether we're out of IOPS on our storage, and whether and we're also concerned about where the latency is coming from in the storage stack, because being able to figure that out is actually what allows our users to actually change their configuration in a way that will make it faster. What does it actually take to do an investigation here? Basically, there's two different aspects of it. Like I said, collecting data at each level and being able to compare the different levels to each other to figure out where most of the latency is coming from is very important. So for instance, if all the latency is coming from the back-end storage, all the latency is coming from the actual disks that we're writing to, then users are going to say, okay, well, we can make this whole thing faster just by speeding up the disk or buying SSDs or somehow replacing the slow disks that are causing latency. If the problem is happening somewhere in the middle of software or our software, then they'll call our support people. If it's happening above our software, then they reconfigure the network or maybe the database that's connecting to our storage. So that's really nice. We would really like to do that, and that's something that we're working on, is providing all these different levels. Right now, we only have visibility into the product that we're actually working on, because that's where DTrace actually is installed. It would be awesome if they get it on other platforms that are running the database, having DTrace probes that are actually probing the database itself. But right now, that's not feasible. So we're relying on inferior tools. The other way that users can figure out what's going on with the performance problem is by drilling down into a particular level in this IO stack. This is basically what we've been building so far, and it's sort of pawned off of tools that were built at Sun and Joanne, I think by Brendan mostly, and probably some of his colleagues. I'll give you an idea of more sort of what that looks like. The idea behind drilling down into a particular layer is that you want to narrow down the set of I/O paths that you care about that go through that layer. So, for instance, in this diagram back here, you have, in a simple case, you have one path that goes through this whole stack. But in reality, you have lots and lots of different paths. You have paths for reads, paths for cache reads, paths for writes, paths for synchronous versus asynchronous writes, and so on. In here, we're even using NFS and SWD, so you'll have paths for both of those. Anyway, you get the point. So what you need to be able to do is somehow limit the number of things you're looking at to figure out where the actual problem is coming from. So in this example that I mocked up here, let's say that you're a database administrator and you hear that service is slow, but you don't know anything else yet. You pull up your dashboard, you see a graph, several graphs of different parts of your system, and NFS latency is a little slow. So you decide to look at it by client to see which databases that are connected to it are actually running slowly. That might reveal some information to you about which client is experiencing the worst pain, and then you can limit what the set of things that the set of probes firing to only relate to that client. So, for instance, you can go down to NFS latency for that particular client and look at another variable that might be changing which path you're taking. So, for instance, whether it's a read or a write is pretty relevant. So, let's say that you look at that and you see that writes are the long-running process here. And so, you'll then look at NFS write latency for that particular client, and you can see, whether it's synchronous or asynchronous. Maybe you'll figure out that synchronous writes are the ones that are taking the longest time. So, what does that actually do for our users? It actually tells them, a whole lot more than they did before. And that's really useful both for them and for us, because the user then is able to either come up with a solution to the problem by themselves, or they're able to file a bug report with us, or talk to our support staff in an intelligible way. Really knowing what they're talking about, they're able to monitor whatever they need to. They don't have to trust us for performance statistics. They can run the statistics themselves. In the end, it saves us, it can save us a lot of time, save them a lot of time as well. So now getting back to the actual DTrace in the school. I've been talking at a pretty high level, and it's going to stay that way. This is just good code down here. But the basic idea is that in order to provide these two different operations, either splitting on a variable, like looking at latency by client, like we were talking about before, or narrowing down, are both provided by these facilities that are built into DTrace. latency, as Adam showed, can be described as this quantized aggregation, and by giving different keys to the latency aggregation that you're collecting, you can do that breaking down. And by adding new conditions to that condition line right after the probe definition, you're able to limit the set of probes that will actually fire. So as you can see, I basically map out the same set of operations, breaking out by latency, breaking out by IP address, then setting the IP address and breaking down by operation, and then setting the IP address clearance, setting the IP address and the operation type to be a write, and then breaking down by whatever is sequence around. So in order to actually build this framework, what we did was basically template DTrace out as you can imagine. The user specifies the constraints that they care about and the variables that they want to see displayed, basically sliced. And we'll translate those constraints into DTrace conditions. The user also supplies how often they want this data to be queried at, and they can, and then we'll fill out the template and run the resulting script. Unfortunately, that doesn't solve all our performance problems, or all our support problems around performance by itself. Our support staff is constantly being asked questions like, we were having performance problems last Friday, and we were hoping that you could really help us figure out what was going on then. And of course, right now, all our support people can say is, well, we can help you by running some simulated workload that hopefully was similar to what we did on Friday night. That's the best you can do. So what we're doing now is collecting the data and storing into MongoDB. We always store a few high-level probe data, and that allows us to get at least a high-level view of what was happening in the system last Friday. Even if it's not quite enough to do a full performance investigation, it's a heck of a lot better than nothing. That at least gives us an idea of where our developers can start looking for ways to improve performance. As we work through the support case with the customer, we can use that as a starting point for where the problem should have been. We can also use it to help actually design a workload that's going to simulate the same conditions that were happening at the time of the performance issue. The reason that we use MongoDB is because we weren't terribly concerned about the ASCII properties of storing these performance data points. We also don't know exactly what the schema of the data points is before we create the probes. And there's also a few small features in MongoDB that make it a little bit more convenient and nice to do logging type applications like this one. So the problem that comes up immediately after you start collecting data constantly is that you're going to store a ton of data. In order to reduce the amount you have to store, these are some basic ground rules that we're following. Don't collect data too frequently. 5 seconds is plenty fast enough to have a nice interactive screen where you can see the data points coming up. Being able to compress the readings over a larger time range than that 5 second sampling interval as those data points get older makes it a lot less storage hungry. Finally, you can delete them after a sufficient amount of time has passed. We decided around 2 weeks is plenty. Nobody's going to come to us with performance problems that they had 2 weeks ago that they haven't been collecting any data for. But we were a little bit worried that people would be collecting data during a performance investigation over a couple of days, and that would cause their data to be compressed before they were done using it to find grain. We also allow the users to prevent data from being compressed or deleted by explicitly saving a specific time range that they care about. So, as a summary, we are using DTrace to enable our users to figure out what performance problems they might have, take our support people out of the loop, allow them to get their their database is running back to normal speed as fast as possible. And we think that our customers are going to like it, and our support staff will like it, and hopefully we're right about that. All right, that's all I got. If anyone has any questions, thanks a lot.